What if our universe is not the first? The question falls like a stone into the still water of thought, sending ripples that reach every shore of what we believe we know. For generations, the Big Bang has been treated as the ultimate curtain rise, the first flash of existence from nothing. But what if that flash was not a beginning at all? Only a doorway opening from somewhere else? Imagine standing at the edge of a vast, lightless ocean. For centuries, humanity has stared out over that water, believing it endless, believing the waves were born with the first dawn. Now, a whisper comes across the dark. Perhaps the tide came in from another sea beyond the horizon. Perhaps our cosmic story began not as a burst from emptiness, but as the aftermath of something collapsing, dying, and yet creating. The standard model of the Big Bang has an almost comforting clarity. Nearly 14 billion years ago, space itself expanded from an unimaginably dense, hot point, a singularity, flinging matter and energy outward, cooling, forming atoms, then stars, then galaxies, then us. It is a narrative of emergence, the universe blooming like a flower from a single seed. But the seed itself remains unexplained. We have equations that trace the first moments after the bang, yet they fall silent when asked what came before. The singularity sits like a blank note in the score of creation, daring us to ask whether it was truly the first sound. Now, picture a dying giant star in some ancient universe long before ours. It collapses under its own gravity, its core folding in on itself until the very fabric of space can no longer resist. A black hole is born, a place where light cannot escape, where matter and time themselves plunge inward toward an abyss. To us, black holes are endings. But what if, hidden within that collapse, there is not merely destruction, but a passageway? What if the death of a star in that other universe ignited the birth of ours? Physicists have long wrestled with the singularity inside a black hole. According to Einstein's equations, it is a point where density becomes infinite, and the known laws of physics unravel. But some modern theories suggest that this is where new space can bud off from the old, as if the black hole's core were less a tomb than a womb. A region known as the event horizon hides this genesis from any outside observer. Beyond that horizon, time and space may curve and twist into something separate. A bubble universe expanding beyond the grasp of the parent cosmos. From the outside, it looks like a dead star's grave. From the inside, it feels like a big bang. Think of a candle burning out. To the watcher in the room, the flame disappears. But if the dying ember could cast a spark across a gap to light another candle elsewhere, then the end of one fire would be the start of another. In this metaphor, the black hole is that bridge, an invisible spark leaping from collapse to creation. The cosmic rebirth hypothesis dares to ask, could every black hole be the seed of a new universe? If so, then our universe may be just one among an endless lineage, each born from the ashes of another, like pearls strung through time on a thread we cannot see. The implications are dizzying. Our cosmic dawn, that first brilliant rush of expansion we call the Big Bang, may have been the quietest moment of all, a birth taking place in the hidden heart of something else's death. For most of the 20th century, cosmology resisted such speculation. The Big Bang itself was once controversial. It displaced the older idea of an eternal, steady-state cosmos. Now it stands as the most successful theory we have, supported by the fading glow of the cosmic microwave background and the observed expansion of galaxies. Yet even this well-tested model does not claim to explain the singularity. It only describes what happened a fraction of a second after it. The moment before remains veiled. The black hole rebirth scenario slips into that veil like a phantom, offering a possible answer to the forbidden question: what came before time as we know it? Some scientists point out that the equations of general relativity allow for such a passage. The collapse of matter could reach a bounce, a transition where gravitational compression flips into expansion, birthing a new, disconnected region of space-time. Quantum gravity, still unfinished, hints at the same possibility: that singularities may not be terminal points, but bridges across a deeper landscape. We have no direct evidence for this yet. No telescope can peer beyond an event horizon, and yet the idea refuses to die. It lingers because it solves a haunting puzzle: how to explain the birth of our universe without appealing to a creation from absolute nothing. If this hypothesis is true, then our cosmos carries a hidden ancestry. The ripples of the Big Bang would be less like the opening chord of a symphony and more like the first note of a new movement in a song that has been playing forever. Every galaxy, every star, every life would be the unfolding of a story that began when another universe met its end. And this is where the paradox deepens. If universes are born from black holes, then each dying cosmos feeds the next. The cycle may be infinite with no ultimate beginning, or perhaps each generation of universes differs slightly from its parent, as if the conditions of physics themselves evolve. This raises the eerie possibility of a kind of cosmic natural selection. Only universes that form many black holes give rise to more universes. So over unimaginable epochs, the multiverse might be tuned for black hole production, and indirectly for the emergence of stars, planets, and life. But let us return to the simplest and most unsettling image. Somewhere in a universe now long vanished, a star collapsed. Its core shrank past all resistance, crumpled into an abyss so deep that even light could not escape. From that moment of utter implosion, a new expanse of space unfurled. Our expanse. The galaxies we see glittering in the night sky. The atoms that make our blood and bones. The time we measure in our lives. All of it might have begun as a spark in the heart of that collapse. It is a thought both humbling and strangely consoling. The end of one world became the dawn of another. Creation and destruction are not opposites but phases of the same grand process. And if this is so, then when we gaze at the dark mouth of a black hole, we may be looking at more than an ending. We may be glimpsing the cradle of other realities. This possibility changes the nature of the mystery itself. The Big Bang is no longer just a question about origins, but about connections. Connections across cosmic generations, across deaths and births of universes. And with that, a final lingering wonder arises. If our universe was born in the heart of a dying star in another cosmos, what might be born one day in the heart of ours? Everything you have ever seen, every star that has ever shone, every ocean that has ever risen to the moon, every thought that has ever crossed a human mind, was once compressed into a region smaller than an atom. Not just the matter, but the space that contains it. Not just the galaxies, but the very distances between them. That is the story the Big Bang tells us. A story that begins with an almost impossible density and heat, and then, in an instant, begins to expand, Close your eyes and imagine that first moment as science describes it. A universe less than a trillionth of a second old. No stars, no atoms, not even light as we know it. Only a seething quantum froth of energy packed so tightly that space itself churned and boiled. From that unfathomable seed came the expansion of all things, an inflation so swift that in a heartbeat the cosmos swelled from subatomic scales to macroscopic dimensions, carrying with it the seeds of everything that would follow. It was not an explosion into pre-existing emptiness. It was space itself stretching, as if the loom of reality had suddenly been pulled wide. Inflation, that brief epoch at the dawn of time, solved certain riddles that had long puzzled cosmologists. It explained why the universe looks so smooth on the largest scales, why distant regions separated by billions of light-years share nearly identical temperatures, and why space appears flat rather than curved. Yet inflation itself is a mystery, a mathematical idea that fits the data but does not yet reveal its own origin. What drove that exponential swelling? What field, what mechanism flipped a switch that let the universe balloon faster than the speed of light? As the expansion slowed, energy condensed into particles. First the most fundamental quarks and gluons, then protons and neutrons, bound together in a dense primordial plasma. For the first few minutes, the universe was a cosmic forge hotter than the core of any star, fusing hydrogen into helium and a trace of lithium, the first alchemy of creation. Still, there were no atoms, no light that could stream freely. The universe was an opaque sea of charged particles and radiation, a blinding fog through which photons scattered endlessly. For almost 380,000 years, the newborn cosmos expanded and cooled until it reached a critical threshold. Electrons slowed enough to bind to protons, forming the first neutral atoms. The fog thinned, light could finally travel unhindered. The universe became transparent, releasing a faint glow that has crossed nearly 14 billion years to reach us. The cosmic microwave background, the oldest light we can see. Its nearly uniform temperature across the sky is a frozen memory of that primordial dawn, a whisper from a time before stars. And then began the long gestation of structure. Tiny fluctuations imprinted during inflation, minute ripples in the density of the early plasma, grew over hundreds of millions of years under the pull of gravity. Matter clumped together, forming the first stars, then clusters, then the grand, swirling galaxies. In that unfolding lay the preconditions for worlds and life, and eventually for the minds that would wonder about their own beginnings. This is the familiar narrative, the one drawn from decades of observation and theory. It is precise enough to describe the abundance of light elements, the pattern of the cosmic microwave background, the clustering of galaxies. Yet, for all its success, it tells us nothing about what set it in motion. We can write equations for the first fractions of a second after the Big Bang, but we cannot explain the singularity itself, that initial state of infinite density and zero volume where our physics falters. The laws we trust simply do not apply when space and time themselves are squeezed out of existence. Here is where the story starts to feel incomplete. The Big Bang model explains how the universe evolved, not why it began. It assumes a singularity, but cannot derive it. It describes expansion, but cannot say what ignited it. Like a play that opens on the second act, it leaves us wondering what preceded the curtain's rise. Consider also the puzzle of the physical constants, the strengths of gravity, electromagnetism, the masses of fundamental particles, all seem to lie in narrow ranges that permit the formation of long-lived stars and complex chemistry. Had they differed slightly, the cosmos might have expanded too quickly for galaxies to form, or collapsed into black holes before life had a chance to arise. The Big Bang model does not tell us why these numbers are as they are. It takes them as given, but their apparent fine-tuning cries out for explanation. Even inflation, that elegant solution to so many early universe puzzles, confronts us with new enigmas. The field that drove it is hypothetical. We have no direct evidence of its nature or origin. Did inflation begin spontaneously, or was it triggered by some prior event? If it occurred once, why not again and again, spawning a multitude of universes beyond our horizon, each with its own physical laws? The Big Bang, once thought to be the singular birth of all things, may instead be only a local eruption in a larger multiverse, an island universe among countless others. The singularity itself remains the most stubborn barrier. As we trace the equations of general relativity backward in time, the density and temperature grow without bound, until the math collapses. It is as if the very language of physics fractures at the threshold of the beginning. Beyond that point lies a blank we cannot fill. Not with telescopes, not with particle accelerators, not yet with any theory we possess. Imagine an ember glowing in the dark, inflating in an instant into a sea of light. Yet when you try to picture the moment just before the ember, your mind encounters only silence. Imagine an equation that predicts the curve of space and the birth of stars, yet its symbols fragment as they near the singularity, as if the law of cause and effect itself cannot cross that boundary. This is the paradox at the heart of the Standard Model. It describes the unfolding of the universe, but not the spark that set the unfolding in motion. For the cosmologist, this is both humbling and tantalizing. We can read the afterglow of creation, map the large-scale structure, and infer the first few instants of cosmic history. Yet we are still standing outside a locked door. The origin, the true first moment, remains hidden. To comprehend it, we may need a new synthesis of quantum physics and gravity, a deeper law that reveals how space and time can emerge from something more fundamental. Or we may need to accept that the word before has no meaning when applied to the birth of space-time itself. Until then, the Big Bang remains an incomplete origin story. It gives us a luminous account of how the universe evolved from a hot, dense beginning. But it does not tell us why there was such a beginning, or whether it was unique. Somewhere in the equations lies a deeper answer. But for now, the math breaks where the mystery begins. And so, the paradox lingers. Everything we see, every galaxy and atom, once fit inside a speck smaller than an atom. Yet the moment that speck came to be lies beyond our science. We are left with a question that haunts the edge of reason. If the Big Bang was not the first cause, then what, or who, or what kind of law set the ember alight? In the heart of space, there are places where the ordinary order of things ceases to hold. They are not stars, not planets, not even true objects in the usual sense. They are absences shaped by gravity, hollows where light itself is bent inward and trapped. We call them black holes. They were once thought to be mere mathematical oddities, strange consequences of Einstein's equations. Now we know they are real as the stars that collapse to form them, and as real as the galaxies that swirl around their invisible hearts. Picture a star far heavier than our Sun, burning through its nuclear fuel. For millions of years it has fought a quiet war. The outward pressure from its fusion fire counterbalances the inward pull of its own gravity. When the fuel runs out, the balance breaks. The core implodes in a fraction of a second, squeezing matter so tightly that no known force can resist. The outer layers explode in a supernova, a blaze bright enough to outshine an entire galaxy for a brief moment. But the core does not merely crumble. It falls past the point of return, collapsing into a singularity, a region where our physics predicts density without limit, where space and time themselves buckle. Around that singularity forms the event horizon, the invisible boundary beyond which escape is impossible. To an outside observer, anything falling in seems to slow as it approaches the horizon, its light stretched into redder and redder wavelengths until it fades from view. To the object itself, the crossing is unremarkable. There is no wall, no flare of energy, just a one-way descent into the unknown. Inside, the very roles of space and time exchange. All paths lead inward. Forward in time now means moving closer to the singularity. What was once a place becomes a destiny. It is tempting to think of a black hole as the ultimate dead end. The crushing gravity consumes stars, planets, entire clouds of gas. Yet the more we study them, the more they seem to defy that grim simplicity. Quantum theory suggests they are not perfectly black, but emit a faint radiation, Hawking radiation, and can eventually evaporate over unimaginable timescales. The equations of general relativity, when pushed beyond the horizon, hint at something even stranger, that the singularity may be not just a point of annihilation, but a bridge, a passage to a new region of space-time. Here lies the paradox that has stirred both dread and wonder in modern cosmology. The ultimate grave may be a cradle. The very feature that makes black holes so terrifying, their ability to pinch space into an infinitely dense point, may also make them fertile. In that unimaginable compression, conditions might arise for a new universe to bud off, disconnected from the parent cosmos. To us, it appears as a silent, devouring void. To whatever lies on the other side, it might appear as a sudden eruption, a Big Bang. Physicist Lee Smolin has gone further, proposing a bold idea sometimes called cosmological natural selection. He imagines a vast evolutionary process across generations of universes. Each universe that forms black holes gives birth to new universes within them. And in turn, those offspring that happen to have physical constants favorable to forming many black holes will produce even more descendants. Over eons beyond human comprehension, universes could be naturally selected to maximize black hole production. In such a picture, the apparent fine-tuning of our own universe, its balance of forces that allow for long-lived stars and heavy elements, is no accident. It is a trait passed down because universes with these properties reproduce more successfully. The idea is speculative, unproven, and perhaps unprovable with current tools, but it is profound in its implications. It suggests that the cosmos is not a single, isolated burst of creation, but an ongoing lineage, with black holes as the reproductive organs of reality itself. Every giant black hole at the center of a galaxy could be not just a sinkhole of destruction, but a cosmic womb. In their dark hearts, new space-time might be sprouting, New stars may one day blaze, and perhaps even new forms of life will wonder about their own beginnings. Another theorist, Nikodem Popovsky, has offered a more concrete mechanism. He argues that the intense twist of space-time inside a black hole, its torsion, could prevent the formation of a true singularity. Instead of crushing matter into infinite density, the twist could cause a bounce, like a spring compressed to its limit, and then released. That bounce could ignite expansion on the other side, much as our own universe expanded after the Big Bang. In this view, each black hole acts as a one-way wormhole, funneling matter and energy into a new expanding universe that is causally disconnected from its parent. The doorway is hidden from us by the event horizon. We cannot peer in, and nothing can return. But the bridge may still be there. Visualize a whirlpool in the sea. From above, you see water spiraling inward, vanishing into a dark center. But imagine if at the bottom of that whirlpool there was not a hole in the ocean floor, but a channel leading to another ocean altogether. From within that other sea, the whirlpool would appear not as a drain, but as a fountain. The same dynamics of gravity that collapse a star here might set loose the expansion of a cosmos there. This picture reframes black holes not as endings, but as transitions. It offers an answer, however conjectural, to the question the Big Bang leaves hanging. What came before? Perhaps nothing before in the usual sense, because the time inside our universe began at its own Big Bang. But there might have been time in the parent universe, and a chain of such births stretching backward, without a first link. There is something almost organic in this vision. Instead of a universe that begins once in a singular miracle and will someday fade into heat death, we see a cycle of death and rebirth, of collapse and renewal. Each black hole is both tomb and womb, each singularity both a wall and a gateway. We become, in a sense, part of a grand genealogical tree, our own cosmos, an offspring of another, destined perhaps to seed future universes when our stars grow old and our own black holes bloom. But this grand idea meets the cold limits of evidence. We cannot send a probe into a black hole and retrieve data. The event horizon is a veil that no information can cross outward. We can infer, calculate, simulate, but we cannot yet confirm. We know black holes form from collapsing stars and from merging neutron stars. We observe their gravitational waves as they collide. We image the shadow cast by their horizons. All these belong to the outside story. The inside remains conjecture. Still, even the outside view is awe-inspiring. Consider the supermassive black holes at the centers of galaxies. The one in the Milky Way, Sagittarius Abers, weighs 4 million times as much as the Sun. In other galaxies, we find behemoths billions of solar masses heavy. They shape the growth of galaxies, stir the gas that births stars, and flare as quasars bright enough to be seen across the universe. These dark hearts may also be the seeds from which galaxies grew in the first place, tying the story of cosmic structure to the story of these gravitational abysses. If such objects also serve as cosmic gateways, then the universe we inhabit is not an isolated bubble, but part of a vast nested hierarchy. Like Russian dolls, each contained within a larger one, each born from the core of another. The thought is both dizzying and strangely elegant. It suggests an infinite regress, and yet also a pattern. Life from death, expansion from collapse. The paradox that space and time swap roles inside a black hole is more than a curiosity of mathematics. It may be the very key to this regenerative vision. To fall into a black hole is, in a sense, to fall forward in time toward the singularity. But if at that singularity new space-time sprouts, then the fall forward in time here becomes an outward rush of space there. The ultimate endpoint of one universe's timeline is the opening chapter of another's. If this picture holds, the evidence may be all around us, staring at us from the silent black centers of galaxies and from the invisible remnants of long-dead stars. Every black hole we observe could be more than it seems, each a hidden passage to elsewhere. Our telescopes show only their consuming mouths, but behind those horizons may lie fireworks we can never witness. The birth of new time, the spreading of new light, the rise of new questions. And so we come to a strange realization. The greatest mysteries of origin may not lie in the distant past, but in the dark hearts scattered across the present universe. To understand where we came from, we may need to understand what black holes truly are. Not merely as astrophysical objects, but as potential portals. They remind us that in the cosmos, endings and beginnings may be inseparably intertwined. The idea does not diminish the awe of the Big Bang, it deepens it. Our universe's expansion, its galaxies and stars, may be the inside story of a black hole that formed in some other, older cosmos. And one day, far in the future, our own black holes may give rise to new expansions in realms we will never see. The graveyards of stars may be nurseries of universes. To contemplate this is to feel the scale of both our ignorance and our inheritance. We live in a universe whose origin may be hidden in a collapse we can never witness, and whose descendants may be born from collapses yet to come. The dark hearts of black holes, once symbols of finality, now glow in the imagination as gateways, as bridges from what dies to what begins. A single black hole in our universe could have birthed an entirely new cosmos. The thought lands like a spark on dry leaves, quick to ignite the imagination. We have always pictured black holes as devourers, as endings without appeal. But now we must consider them as seeds. Seeds hidden in darkness, falling inward through an unseen threshold, and sprouting elsewhere into vast, star-lit worlds. If that is true, then the history of existence may not be a single story, but a branching lineage, each universe an offspring of another. Consider the tree as a symbol. We usually think of a tree as reaching upward, toward light, spreading its branches wide. But every tree also grows downward, sinking roots deep into soil. If universes are born from the collapse of stars, then our own cosmos is like a tree whose roots lie in the depths of ancient worlds we can never know, and whose branches may be growing even now from the black holes that fill our night. We stand, like leaves at the tips of the branches, seeing only the sky, unaware of the tangled roots beneath us. Smolin's idea of cosmological natural selection gives shape to this vision. Imagine a primordial population of universes. Some are short-lived, expanding so rapidly that matter never condenses into galaxies. Some collapse almost as soon as they begin. A few, by chance, have just the right balance of forces to allow stars to form, to burn for billions of years, to die and leave behind black holes. Those few become parents, each black hole spawning a new, separate universe. Over unimaginable stretches of metatime, this process favors the physical laws that make black holes prolific. Our universe with its galaxies rich in stars that end as black holes, may be a product of this vast, hidden selection. This hypothesis turns fine-tuning from mystery into inheritance. We wonder why the constants of nature seem so delicately adjusted. The strength of gravity, the mass of the proton, the ratio of forces that govern nuclear fusion. If gravity had been slightly weaker, the first stars might never have ignited. Slightly stronger, and the universe might have collapsed back into itself before galaxies had time to assemble. In the standard view, this tuning is either a lucky accident or evidence of deeper, undiscovered principles. In Smolin's vision, it is the outcome of a long, unseeable history. Universes that make many black holes pass on their traits. Universes that do not simply vanish. Pause for a moment on the implication. It suggests that the cosmos has a kind of evolutionary memory, not written in DNA but encoded in the capacity to form stars and to let them die into black holes. Our own existence, our very capacity to think about these matters, depends on that tuning. Life needs long-lived stars and complex chemistry. Those, in turn, depend on the same constants that favor black hole production. We are, in that sense, the byproducts of a reproductive strategy writ on the grandest scale. Yet, this vision also brings an unsettling intimacy. We often speak of the universe as singular, unique, the only one. But if every black hole can bud off a new universe, then our universe itself is just one branch on an immense, unseen tree. The night sky, filled with galaxies, becomes not merely a panorama of remote suns, but a nursery of potential heirs. Each galaxy with its central black hole may be carrying within it a gateway to another realm. Each dying star could be planting a seed for a future cosmos. And if there is a lineage, then there is a past we cannot see. Somewhere in the unknown depths of the multiverse, a star in another universe long ago collapsed, its death throes igniting the beginning of our own. We are the children of a catastrophe that unfolded beyond any horizon we can observe. This realization bends the arrow of time into a loop, turning our thoughts backward even as we look forward. In the branching of such a cosmic tree, variation is inevitable. Each new universe born from a black hole might inherit most of the physical constants of its parent, but not all. Quantum fluctuations at the moment of formation could shift the values slightly. Most variations may be sterile, leading to empty or short-lived universes, but some will be fertile, allowing stars and black holes, and thus the lineage continues. Over inconceivable spans, the population of universes would drift toward those combinations of constants that maximize black hole formation. Picture the roots of this cosmic tree as black holes themselves, each one a dark, collapsing knot of matter. From that hidden root grows a branch, and on that branch blossom galaxies like leaves. From some of those galaxies fall seeds, more black holes, which themselves sink into deeper darkness, sprouting still other branches. It is a forest of realities, but each tree within it is invisible to the others, separated by horizons that no signal can cross. Such a vision carries philosophical weight as well as scientific intrigue. It offers a naturalistic explanation for fine-tuning without invoking external design, but it also reshapes our sense of belonging. We often ask whether humanity has a purpose in the grand scheme. In this branching lineage, purpose may be replaced by consequence. We exist because our universe's laws were fertile for stars, and thus for black holes, and thus for life. We are an incidental but inevitable bloom on a tree grown to bear other fruit. And yet, there is wonder in that too. If the family tree of universes tends to favor conditions that allow complexity, then we are not a cosmic fluke, but part of a pattern that stretches beyond the reach of our telescopes. We may be rare in detail, but not in principle. We may be one expression of a principle that favors not just black holes, but, as a byproduct, minds capable of reflection. Here another paradox rises. By understanding black holes, by learning to read the record of the cosmos, we may be peering back into our own ancestral soil. To know our beginnings is to look into the hearts of the dark objects that dot our sky. We study them for the light they bend, for the waves they send across the fabric of space. Yet we suspect that what we see is only the surface of a deeper tale. In contemplating this family tree, we must confront also the prospect of our own contribution to it. The universe we inhabit is still young by cosmic standards. Its stars will burn for trillions of years more. In the far future, as they exhaust their fuel and collapse, as galaxies drift apart and fade into darkness, the black holes will remain. Long after the last starlight dims, they will still be there, silently holding mass and memory. Each may in time serve as the seed of another expansion, a new universe blossoming from our own long-cooled ashes. Imagine that final epoch. The galaxies have scattered beyond one another's sight. The stars have winked out, and only black holes remain, slowly evaporating over unimaginable spans. As each reaches the end of its slow decay, or perhaps before, it may pinch space once more into a new bud, another branch on the tree. From the death of our universe could arise the dawn of others, perhaps bearing constants only slightly changed, perhaps enough to give rise to different patterns of matter and thought. We cannot know whether this cycle has any ultimate beginning or end. Perhaps it stretches back without origin, an endless forest of universes feeding one another. Perhaps it will continue without conclusion, each generation sowing the seeds for the next. In that vision, immortality belongs not to individual beings, nor even to particular worlds, but to the process itself, the ceaseless passing on of the power to create new space, new time, new stories. There is a humility in seeing ourselves as part of such a lineage. We are not the pinnacle, not the purpose, not the first or the last. We are a flowering of the conditions that also favor the growth of black holes, and thus of future universes. The constants we measure in our laboratories, the masses of particles and the strength of forces, are not mere numbers handed down from nowhere. They may be the inherited traits of a successful ancestral universe, honed by an unseeable selection over eons. And there is also a strange dignity, for in being able to contemplate these possibilities, we become the first known species in this universe to suspect that we are part of something larger than a single cosmic birth. Our curiosity may be the most delicate bloom on this branch of the tree, a sign that the lineage that produced us can also produce minds capable of tracing it. When we look at the black holes scattered across our sky, we see both our roots and our descendants. They are tombstones of stars, and yet may be the cradles of futures. To study them is to read the genetic code of the cosmos. To understand them may be to understand why the universe is the way it is. So the story of the family tree is not just about distant, unreachable realms. It is about the very fabric of the reality we inhabit. Our constants, our galaxies, our lives may be the outcome of a long, unseen chain of cosmic births. And in that chain we may one day play our part. As the black holes of this universe sow the seeds of universes yet unborn. The oldest light in the universe still carries a memory of what came before. We usually think of the cosmic microwave background, the CMB, as a photograph of the young cosmos, a faint, cold glow stretched across the sky. But, to some scientists, it is more like a palimpsest, an ancient manuscript written over yet still bearing traces of earlier words. The universe itself may be trying to tell us a secret hidden beneath that glow. Nearly 13.8 billion years ago, after the first hot, dense moments of the Big Bang had passed, the universe cooled enough for electrons and protons to combine into neutral atoms. The fog of charged particles thinned, and for the first time, light could travel freely. That light still streams across space today, red-shifted by expansion into microwave radiation. When we map it with our telescopes, we find it nearly uniform, with tiny fluctuations that seeded the structure of galaxies. It is, as far as we know, the oldest image we can take. A portrait of the universe when it was only 380,000 years old. But the more carefully we examine that portrait, the more we notice small irregularities, tiny deviations that do not fit perfectly with the simplest Big Bang models. Some patches of the sky are just a little warmer or cooler than expected. There are curious alignments, faint asymmetries between hemispheres, strange cold spots that some believe may be the scars of something extraordinary, perhaps even evidence of a cosmic event that occurred before the Big Bang's familiar expansion began. If our universe was born from the collapse of a black hole in another universe. Could some whisper of that origin still echo in the CMB? The thought is bold, but physicists have asked it in earnest. They suggest that the violent bounce at the birth of our cosmos might have left minute imprints in the distribution of temperature and polarization in the background radiation. Such imprints would be subtle, patterns in the faint ripples of the oldest light, but not necessarily beyond our reach. One place to search is in the spectrum of primordial gravitational waves. In the first fractions of a second, the universe's fabric itself rippled with energy. Inflation predicts a particular pattern in those ripples, a random but statistically well-defined swirl in the polarization of the CMB, known as B modes. Detecting that signal would not only confirm inflation but also open a window onto the physics of the earliest epoch. If, however, the birth of the universe came through a black hole bounce rather than standard inflation, the gravitational wave signature could be different, perhaps weaker on some scales, stronger on others, perhaps carrying a directional memory of the funnel that led from the parent universe into ours. So far, the data is tantalizing but incomplete. Instruments like the BICEP and Planck telescopes have searched for B-mode polarization and found hints, but no definitive signal. Future missions, ever more sensitive space-based detectors and laser interferometers floating far from Earth, may reach the necessary precision. If they detect a spectrum of gravitational waves that deviates from what inflation predicts, we may glimpse the shadow of another story. Another clue may lie in the very geometry of space-time. The standard Big Bang assumes that, extrapolated backward, space and time emerge from a singularity of infinite density, a point where general relativity breaks down. But some approaches to quantum gravity, such as loop quantum gravity, replace that singularity with a bounce. In these models, Space-time has a discrete, granular structure at the smallest scales, like a woven fabric. When compressed beyond a certain limit, it resists further collapse and rebounds, turning contraction into expansion. If that is correct, our universe's Big Bang was not the beginning, but a transition, the other side of a black hole throat. This idea of a bounce has testable consequences. It predicts slight departures from the exact scale invariance of the primordial, fluctuations imprinted in the CMB. It predicts that the largest scale modes, those corresponding to the widest angles in the sky, may be suppressed or show particular correlations. Interestingly, some such anomalies have been reported. An unexpected alignment of the largest fluctuations, nicknamed the axis of evil, and a mysterious cold spot that has resisted conventional explanations. None of these is conclusive, and many may be statistical flukes. But to those searching for signs of a pre-Big Bang phase, they are like faint footprints on an ancient road. Imagine standing by a calm pond and tossing in a stone. The ripples spread outward in perfect circles, unless the pond itself had a current or an uneven bottom. Then the ripples carry hints of that hidden influence. The CMB's ripples may likewise carry whispers of an older current, a pre-existing structure that guided the first moments of expansion. The search extends beyond light to the new field of gravitational wave astronomy. When two black holes merge, they send out tremors that we can now detect with instruments like LIGO and Virgo. These signals come from relatively recent events, but they prove that we can listen to the universe's most violent moments. Future detectors, operating in space and tuned to lower frequencies, may catch echoes from the first second after the Big Bang, or from the bounce that preceded it. The gravitational wave background, if mapped in detail, might reveal a pattern not expected from inflation alone. Another speculative but intriguing avenue is the study of black holes themselves. If every black hole is indeed a gateway, its interior geometry could in principle influence the properties of the offspring universe. We cannot see inside, but we can study how black holes grow, merge, and radiate. If some universal relation holds, if their mass and spin distributions carry a particular fingerprint, it might hint that they serve a reproductive role in the cosmic lineage. All of this work proceeds at the edge of what can be tested. Science demands evidence, and evidence comes only from observation. The danger of such grand hypotheses is that they can drift into metaphysics, untethered from experiment. But we are not yet at that brink. The cosmic microwave background is real data. Gravitational waves are real phenomena. Anomalies in their patterns, if verified and statistically significant, would demand explanation. Whether that explanation points to inflationary quirks, to pre-Big Bang remnants, or to new physics emerging from quantum gravity, is a question that future measurements may answer. There is a subtle discipline in this pursuit, to let wonder lead, but not overtake reason. The idea that our universe emerged from a black hole throat is awe-inspiring, but it must stand or fall by the evidence written in the cosmic fabric. Each anomaly we find may be only noise, or it may be a clue, a glint of something deeper. Each improvement in our instruments may bring us closer to distinguishing chance from pattern. Consider again the notion that the answer may already be in the data. The CMB maps we have today contain billions of data points, each a measurement of temperature or polarization across the sky. Hidden among them could be correlations too faint for us to notice with current methods, but waiting for more refined analysis or better statistical tools. The universe's earliest memory may be encoded like a watermark beneath the visible image, a pattern that requires new insight to reveal. If we do uncover such a signature, a distortion of the primordial ripples consistent with a bounce, or a peculiar directionality in the gravitational wave background, it will not give us a photograph of the parent universe. Horizons are unyielding. We cannot see through them, but it will tell us that the Big Bang was not a singular beginning. It will tell us that our universe bears the birthmark of a deeper process, like a child inheriting a subtle trait from an unseen ancestor. This realization would shift the frame of cosmology. The Big Bang would no longer be the origin, but a chapter, one link in a longer chain. The science would still describe the same expansion, the same physics of stars and galaxies, but it would place them in a grander narrative, a story of inheritance and transformation across generations of universes. To think that we may be able to read such a story in the faint glow of the microwave background or in the whispers of space-time's waves is to glimpse the power of human inquiry. We stand on a small planet, orbiting a modest star, and yet we have learned to measure fluctuations a few millionths of a degree in the oldest light, and distortions smaller than a proton's width in the fabric of space. With those measurements, we hope to answer a question as old as awe itself. Where did everything come from? And if the clues do point to a past before the Big Bang, if they hint that our cosmos once passed through the throat of a black hole, then we will have taken a step, not just in science, but in perspective. We will see ourselves as the heirs of a process older and larger than our universe. The stars we watch at night will seem not just distant, but ancestral, their fates tied to the future of worlds we will never see. The search is far from over. The next generation of CMB observatories, the space-based interferometers, the quantum gravity theories refined by decades more of thought, all these may bring us closer to the truth. Or they may deepen the mystery, showing us that the fabric of reality holds secrets more subtle than we guessed. Either way, the pursuit itself transforms us. We learn to read the universe not just as a map of space and time, but as a text, a story inscribed in ripples and radiation, in patterns of light and motion. And so we return to the image of the tapestry. A vast weave of cosmic history, each thread a line of cause and effect. We live on one bright strand, but suspect that others lie beneath and beyond. In the edges of the weave, in the faint ripples and subtle knots, we may find the evidence of other stories, the marks of passages from one universe to the next. To recognize such patterns would be to glimpse our true inheritance, to know that our own cosmic beginning was itself the echo of an earlier ending. The ultimate beginning may be an illusion. We have been trained by our stories, our religions, our sciences, to seek an origin, a first cause, a single spark at which all chains of explanation must end. Yet the idea that the universe itself may be only one link in an endless sequence erodes that notion. If the Big Bang was not the first dawn, if it was the bloom of a bud on a branch that grew from some older, unseen root, then the search for a singular beginning becomes like chasing the horizon. No matter how far we walk, it retreats before us. To face this possibility is to confront a profound shift in perspective. We are accustomed to imagining ourselves as living in a cosmos with a finite past and an eventual future, with our lives set against the arc of a single grand story. But if universes have been giving birth to universes for as long as there has been time, then the stage on which we appear is not a lone theater, but one of countless halls in a vast and ancient architecture. The play we are part of has no opening act, only recurring scenes with new actors. This realization does not make the cosmos less mysterious. It deepens the mystery. If there was no single origin, we must ask a subtler question. Why is there something rather than nothing at all? We move from the search for a first cause to the contemplation of an unbroken process, a cycle of collapse and renewal. The question changes shape, but does not lose its weight. In such a vision, the meaning of our existence cannot rest on being near the beginning, because there was no beginning. It cannot rest on being near the end, because there may be no final end. Meaning must arise from participation itself, from being part of the great unfolding of forms, the flowering of complexity that rides upon the larger currents of birth and death of universes. We become like a single leaf on an endless tree, brief in our own season, yet inseparable from the life of the whole. For some, this perspective carries a kind of liberation. The demand for a first cause has always pressed reason against the limits of comprehension. To release it is to accept that we inhabit an eternal process that needs no external foundation. For others, it brings unease. A single origin suggests intention. A chain of universes suggests indifferent mechanism. We want a story that begins and therefore might have a reason. An endless lineage may feel like a riddle without answer. We may find, however, that this recognition does not diminish, but rather heightens the value of our moment. In a cosmos where universes succeed one another, we are a fleeting expression of a vast continuity. Our lives, our thoughts, even our questions become the brief flowering of a pattern that has endured across eons. That pattern, the rise of stars, the forming of worlds, the emergence of minds, is itself what persists. We are not the beginning of meaning, but we are one of the places where meaning is perceived. Consider the paradox that we ourselves, in reflecting upon these things, give the universe a way to know that it is not alone, that it has a history. We are the self-awareness of one particular cosmos. In a lineage of countless universes, most may be barren of observers. The fact that we are here to wonder at all is a sign that the chain sometimes yields more than mere repetition. It yields consciousness capable of wonder. If rebirth is the fundamental rhythm of reality, then death, whether of stars or of universes, is not ultimate erasure, but transformation. Our universe will one day darken, its stars burning out, its energy dissipating. That vision has often filled thinkers with dread. Yet if the collapse of matter into black holes is itself a sowing of seeds, then the death of our cosmos will be the prelude to new worlds, new dawns. The finality we fear is only a gateway, as the Big Bang may once have been. This does not grant us personal immortality. We do not survive into the next universe as individuals any more than a single wave survives the breaking of the ocean. But it suggests that the process that gave rise to us, the long weaving of physics and chemistry and life, will find new stages on which to appear. We belong to a pattern more enduring than any single self. A pendulum swings. It reaches one side, slows, pauses, and then swings back. In some visions of cosmology, time itself may behave like this, cycles of contraction and expansion echoing forever. In others, there is no true reversal, only the branching of new universes from black hole throats. The image of the pendulum captures the sense of rhythm, the refusal of reality to settle into a final stillness. We live in one swing of that great pendulum, knowing that others may have come before and others will follow after. Or imagine a hall lined with mirrors, each reflecting another, each image containing yet more images. We are accustomed to looking at one reflection and calling it the original, but in the hall, no single image holds that privilege. The series stretches both forward and backward, and what we call the real is only the one we currently occupy. Such metaphors point toward the philosophical horizon, a place where the distinction between cause and effect, between beginning and ending, blurs into a continuous procession. Science may never give us a first cause. It may only uncover deeper layers of relationship. Yet this itself is a kind of understanding. It tells us that reality is not a single event, but an ongoing act. If we accept that the ultimate beginning may be an illusion, we can ask more fruitful questions. What patterns endure across universes? What properties seem to recur because they allow complexity to arise? What role do black holes play in this continuity? These are questions of inheritance, not of origin, and they are more closely tied to what we can, in principle, observe. On the human scale, this realization invites humility. We often imagine that meaning depends on being central, the center of space, the center of history, the chosen species. The lineage view suggests that we are neither central nor accidental, but integral. One more expression of a process that favors certain forms. That we can know this is itself remarkable, as if the tree had grown a branch capable of contemplating the forest. It also invites a certain gratitude. To exist at all in a universe that allows life is to be the beneficiary of a long history of prior worlds and prior collapses. We live amid the ashes of stars that once shone in the parent cosmos. The elements that compose us, carbon, oxygen, iron, may have been forged not only in the furnaces of our own stars, but in the deeper history of an earlier universe whose collapse made this one possible. To see ourselves as heirs of that lineage is to feel kinship with the vast. Does such a vision change our quest for purpose? Perhaps it shifts the focus. Rather than seeking a purpose imposed from outside, we may seek to understand and participate in the unfolding of this great continuity. We can strive to deepen knowledge, to preserve life and awareness, to act as stewards of the brief flowering of mind in our universe. In doing so, we serve no external command, but align ourselves with the current of creation and rebirth that has carried reality this far. The awe we feel at the night sky may also be deepened. Each point of light is not only a star, but a possible ancestor of future universes. The black holes hidden in distant galaxies may be not only endpoints, but cradles. To gaze at them is to look both backward into the depths of time and forward into possibilities beyond our horizon. In the end, the recognition that the cosmos may be eternal in its cycle does not answer every question. It does not explain why there is existence at all, why there is a fabric to collapse and expand. That mystery may lie forever beyond our reach, or it may someday be reframed by new insight. But to glimpse the chain of universes is to take one step further back in perspective, to realize that our story is not the whole story, but a chapter in a longer book. And in that awareness, there is a quiet shift. We do not stand at the threshold of the universe's story, but inside it, carried along by the same forces that have carried countless worlds before us. We are echoes of a universe that once collapsed, and we may in turn be the echo that seeds another. To know this is to see ourselves not as isolated sparks in the void, but as part of the great pendulum swing of creation. Such knowledge humbles and enlarges us at once. It tells us that we are small in time and space, yet participants in a process vast and unending. It suggests that meaning is not found at a beginning or an end, but in the awareness that arises within the flow. We are not merely witnesses of this flow, but a moment in which it has come to know itself. In this way, the philosophical horizon opens, not as a distant line to be crossed, but as a widening of understanding. It is the horizon of perspective, revealing that the search for a first dawn may have been a question of limited sight. Beyond that horizon lies not a final answer, but a deeper participation in the ongoing mystery. The realization that to exist is already to be part of the eternal unfolding. The next great discovery may not lie among the distant stars, but in the depths of a black hole. For generations we have looked outward, to galaxies and nebulae, to the vast shining fields of space, hoping to find the secret of our origin. Yet the further we gaze, the more we begin to suspect that the key to the story lies not in the farthest reaches, but in the dark hearts scattered among the galaxies, places where light itself cannot escape, where the known laws of nature bend to the edge of breaking. Every black hole we see may be a doorway. To us it looks like an end, a point beyond which we cannot follow. But if the idea of a cosmic lineage is true, then each of those dark hollows may be the beginning of another world. We see only the mouth of the tunnel. On the other side, unseen, another universe may be expanding, with its own stars, its own histories, perhaps even minds that will wonder in turn about their origin. The thought transforms our perception. The night sky becomes a field of seeds, each a silent promise of future worlds. In contemplating these black holes, we are also, inevitably, contemplating ourselves. Our lives, brief against cosmic time, often seem like small, transient flames. We burn, we fade, we leave faint traces. The idea that our entire universe is itself the child of another and may one day give rise to new universes in the collapse of its own stars reframes the meaning of endings. It suggests that death, whether of people, of worlds, or of entire universes, may be less an erasure than a change of form, a passing forward of potential. In every ending, we may glimpse another beginning. The quest for cosmic origins is also a quest to understand the limits of our own existence. We ask what preceded the Big Bang, but the deeper question may be why we long for a first cause at all. Perhaps we seek it because we hope that a beginning implies purpose, that our lives are rooted in something ultimate. If we learn that the universe is part of an endless cycle, we will have to accept that meaning is not bestowed from a single source, but emerges from the continuity itself. That recognition can be unsettling, yet it may also be liberating, for it means that the worth of life is not diminished by the absence of a single first dawn. Imagine the explorers of the future, not journeying outward across interstellar gulfs, but lingering at the edge of a black hole, sending their instruments as near as possible to the event horizon. Their aim would not be merely to map distant galaxies, but to read the deepest inscriptions of cosmic history in the way matter falls, in the pattern of radiation that escapes, in the ripples of space-time itself. They would be standing at the threshold of what seems an abyss, yet peering, in a sense, into the womb of worlds. We can already picture such endeavors, vast space-based interferometers listening to the soft chorus of gravitational waves, extracting from their subtle harmonies the memory of the universe's first moments. Arrays of telescopes tuned to catch the faintest polarization patterns in the ancient microwave glow, hoping to detect the fingerprints of a pre-Big Bang bounce. Quantum theories of gravity tested by their power to predict what happens near horizons where space itself is stretched thin. In these efforts, the boundary between science and story begins to blur, for we are seeking not only equations, but ancestry. Not just how the universe behaves, but how it came to be. The vision that emerges is both humbling and strangely hopeful. We are small, yet capable of tracing our origins beyond our own universe's birth. We are finite, yet able to imagine processes that span countless generations of worlds. We may never travel through a black hole, but with reason, with observation, with patience, we can stand at the edge and infer what lies beyond. The search itself becomes an expression of the same drive that shaped the cosmos. A drive toward complexity, toward awareness, toward passing on what has been learned. In the end, the story we tell about the universe becomes a mirror in which we see our own condition. We are born, we live for a brief time, we die, and from our passing others come. We seek a beginning for our universe, just as we seek a meaning for our lives. Perhaps both searches are bound to find not a single origin, but a chain of becomings. To know this is not to despair, but to recognize that we belong to a continuum far larger than ourselves. A continuum in which each ending is a doorway, each silence a pause before the next word. There is an image that lingers, a single black hole, distant and faintly glowing in X-rays, adrift in the darkness at the center of a galaxy. Around it, stars whirl. Beyond it, the galaxy's spiral arms unfurl like pale rivers of light. To our eyes, it looks like a void, a wound in the fabric of space. Yet in its heart may lie the beginning of other skies, other galaxies, other stories. In that image, the dark is not empty, but pregnant with future dawns. Another image, a child standing beneath a star-specked horizon, lifting a small hand as if to reach for the farthest point of light. The child does not know that each of those points is a sun, and that within the depths of those distant galaxies are black holes, and within those black holes may be entire worlds. Yet the reaching gesture is itself an echo of the universe's own expansion, an impulse to grow, to explore, to seek what lies beyond the known. The future of this quest will not only be about telescopes and equations, it will also be about imagination. To understand that we may be part of an infinite lineage of universes is to expand the scope of our story and, perhaps, the scope of our compassion. We are not merely inhabitants of a single cosmos, but participants in a process that may have no beginning and no end. The discoveries yet to come will not diminish the mystery. They will deepen it, and so we close where we began, with a paradox. We live in a universe that had a birth, and yet that birth may not have been the first. We live under stars that will die, yet their deaths may plant the seeds of future worlds. We search for an origin and find a chain. We seek final answers and find that each answer opens a new question. The door inside the dark remains closed to our direct gaze, but to recognize that it may be there is already to change the way we see the night. We no longer see only the scattered lights of distant suns. We see also the depths between them, the unseen corridors that may lead to other realms. We realize that the quest to understand the cosmos is inseparable from the quest to understand ourselves, finite creatures asking infinite questions. Perhaps one day our instruments will read in the fabric of space-time, the unmistakable signature of a passage through a black hole throat. Perhaps we will learn that our universe carries in its oldest light the imprint of an earlier collapse. Or perhaps we will find only subtler mysteries, new patterns that hint at further depths. Whatever we find, the journey itself will be our legacy. And as we look at the night sky, at the silent black mouths of collapsed stars, we can hold this thought, that in the dark we fear may lie the next great beginning, that in seeking origins we may come to understand not only the universe's story, but our own place within the endless unfolding, that every question we ask is itself a step toward the threshold. What if the true horizon is not the edge of space, but the edge of understanding?